Make a mapping diagram. Is the relation a function? Well, a mapping diagram means you take a bubble, you call it the domain. You take another bubble, you call it the range. And then what you do is you list the domain and range in order in each bubble. So -7, -6, -1, 1, and 6 already in an order. So -7, -6, -1, 1, 6. My range is going to be 7, -5, 7 again, -2, -5 again. So -5, -2, 7. And then we map. -7 goes to +7. Nope. -6 goes to -5. Nope. -1 goes to 7. Nope. 1 goes to -2. Nope. And 6 goes to -5. Nope. Perfectly drawn. Now, is this relation a function? Yes, it's a function because every single x value, every single member of the domain is mapped to exactly one member of the range. Now, it doesn't matter if the range repeats. It doesn't matter if all of these went to -2. But as long as each of these are used once and only once, and you're sending one number only for the domain, you're good. So this is a function. Graph the relation. Is the relation a function? So we have 1, 2, 3, 4, 5 dots. So you are -1, -3. You will live right there. You are 0, 6. You live right there. You are 4, -5. So that's right 4 down 5. You live right there. You are 5, 7, so that's right 5 up 7, so you live right there. And 6, -7 is going to live at 6, -7, bada bing. Now, what makes a graph a function is you have a vertical line. I'm getting different colors. That's what you see on the left there. So you have yourself a vertical line. And at no point, this is me drawing a vertical line, by the way. Isn't that perfect? At no point will this vertical line touch a dot more than once. So you hit the black dot, you hit the red dot, you hit the blue dot, you hit the green dot, you hit the purple dot. And at no point do I hit my dot more than once. Which means, is this a function? Yes, yes, yes. Big, thick letters. Determine the domain and range, and is the relation a function? The domain is all the x values used, so let's list those out. Domain is going to be all the x values used. So if I go left 5, that means my domain is -5. If I go left 3, that means my domain is also -3. Left 1 is -1. Right 1 is +1, right 6 is going to be +6, and right 7 is going to be +7. That's my domain. My range is going to be the y values used. So let's go least to greatest, down -6, so my range is -6, down 3, -3, down 1, -1, up 2, +2, up 5, +5, and up 6, +6. Now, two ways that I can figure out what the domain and range are. I can make myself a nice vertical line. This is me trying to draw a vertical line. That's actually not that bad. I'll give myself a little bit of credit. If my graph passes the vertical line test, that means if I were to pass a vertical line and I only hit each dot once and I don't have two dots on my line at the same time, then I do have a function. And as you can see, as I pass through these 6 dots, my vertical line only hits one dot, if no dots at all. So yeah, this is a function. Now also, if I look at my domain and see that my domain values are going to repeat at any point, then I wouldn't have a function. But my domains don't repeat. -6, -3, -1, 1, 6, and 7. Those guys don't repeat. This is a function. Everybody's happy. Which graph represents a function? Well, the way you determine if something is a function is if it passes the vertical line test. So let me draw a vertical line right there and see if at any point my graph is going to hit this vertical line more than once. Now this is a piecewise function. Any of these open circles here mean that the graph doesn't count there. So if I were to go here and be like, it hits my vertical line twice. No, it doesn't, because you don't count and neither do you. So if I were to pass this through, I'm still touching the graph once, open circle, closed circle, still touching it once, open circle, closed circle, still touching it once. Right here, it fails the vertical line test. So this graph is not a function. Now let's keep going. If at any point my vertical line hits the graph more than once, like it does right there 3 times, it's not a function. If at any point my vertical line hits the graph more than once, like it does right here twice, it is not a function. But when I look at that last guy, I can pass my vertical line and my purple is only going to touch the blue once and only once throughout this whole time. So yeah, this one right here, the bottom right, is going to be my function because it passes the vertical line test. Hooray! Evaluate f of x equals negative 3x minus 5. Find f of negative 8 over 3. This is me evaluating by replacing every x in f of x with negative 8 over 3. So f of negative 8 over 3 has me replacing every x with negative 8 over 3. So negative 3 times, instead of x, negative 8 over 3 minus 5. Negative times a negative is a positive. The 3's cancel out, and so you're going to get 8 and then drop down the minus 5. So f of negative 8 over 3 is equal to 8 minus 5. So f of negative 8 over 3 is going to be 3. And that's how you do it. Evaluate f of x equals negative x squared minus 8x minus 13. Find f of negative 4. Whenever you're evaluating a function, you replace every x in f of x with that number right there. So f of negative 4 is going to have me rewriting this guy but replacing every x with negative 4. So negative 4 squared. And make sure when you plug stuff in, use parentheses. Minus 8 times negative 4 minus 13. So f of negative 4 is going to become, now PEMDAS says do the exponents, so negative 4 times itself is positive 16, but that negative is still lingering out there. Minus 8 times negative 4 is going to be positive 32 minus 13. So f of negative 4 is negative 16 plus 32 minus 13. Negative 16 plus 32 is 16, and 16 minus 13 is going to be 3. So f of negative 4 at the end of the day is just going to be 3. Dunzo. Graph using the given domain. When I'm asked to graph using a domain, I'm going to take all 5 of these numbers, plug them in separately, and see what I get. Okay, so let's do them one at a time and use all the colors that we have. F of negative 5 is going to be 2 times negative 5 plus 2. And let's do this quickly. 2 times negative 5 is negative 10. Negative 10 plus 2 is negative 8. So negative 5, negative 8 is going to look like negative 5, negative 8. Put a dot right there. Okay? Let's do it again. F of negative 4. F of negative 4 is going to equal 2 times negative 4 plus 2. 2 times negative 4 is negative 8. Negative 8 plus 2 is going to be negative 6. So negative 4, negative 6, negative 4, negative 6. There's a dot right there. Let's do it again. F of negative 3 is the same as 2 times negative 3 plus 2. 2 times negative 3 is negative 6. Negative 6 plus 2 is negative 4. So negative 3, negative 4 is going to be this point, negative 3, negative 4 right there. We can kind of see a straight line beginning to develop. That's going to be the case because that is in the form y equals mx plus b. But now I'm going a little not out of order, but I'm skipping a few. So f of negative 1 is going to be 2 times negative 1 plus 2. 2 times negative 1 is negative 2. Negative 2 plus 2 is 0. So negative 1, 0 is the point right here. Negative 1, 0. Last but not least, I'm going to find out what f of 2 is. F of 2 is going to be 2 times 2 plus 2. 2 times 2 is 4. 4 plus 2 is 6. F of 2 is 6. So we go to 2, we go up to 6, and there's our dot. Okay, so these are our 5 dots. This is the graph based off the domain that I have. No, we don't connect the dots because they want us to only graph using the given dots that you're being told. And we always do what we're told because we're good kids and young adults. Thanks for watching. Graph using the given domain. In order to graph numbers using the given domain, what we do is we take our numbers, we plug them into this equation or function one at a time, do the math, get a point. So that's what we're going to do. We're going to have 5 different dots and 5 different numbers that we're going to plug in, and we're going to get these dots that are going to probably make some type of V-looking shape. Now, we won't connect the dots because we're just graphing 5 dots. So let's start out with f of negative 8. F of negative 8 is going to be 2 times the absolute value of negative 8 plus 3 minus 5. Now let's do all of this math. 2 times the absolute value of negative 5 minus 5. Now I'm running out of space, so let's be quick. The absolute value of negative 5 is 5. 5 times 2 is 10, and 10 minus 5 is 5. So when I use negative 8, I get 5, so negative 8 5 is going to be one of my points. I did a lot of hand waving there, so I did a lot of mental math. Hopefully you guys are okay with that. If not, just there's a guy out there named Khan. You can watch him. F of negative 5 is now going to be 2 times the absolute value of negative 5 plus 3 minus 5. So 2 times the absolute value of negative 2. So let's do what we did before. The absolute value of negative 2 is positive 2. 2 times 2 is 4. 4 minus 5 is negative 1. So when I use negative 5, I get negative 1, negative 5, negative 1. Put a dot right there. Okay, let's do it again. F of negative 4 is going to be 2 times negative 4 plus 3 minus 5. The absolute value of negative 4 plus 3 is going to be the absolute value of negative 1. So the absolute value of negative 1 is positive 1. 2 times 1 is 2, and 2 minus 5 is negative 3. So that gets us the point negative 4, negative 3, negative 4, negative 3. Let's plug in 0. F of 0 equals 2 times the absolute value of 0 plus 3 minus 5. 0 plus 3 is 3. So 2 times the absolute value of 3 minus 5. The absolute value of 3 is 3. 2 times 3 is 6, and 6 minus 5 is 1. So when I plug in 0, I get 1. Like that. And one more. When I plug in 3, I get 2 times the absolute value of 3 plus 3, drop down to minus 5. The absolute value of 3 plus 3 is 6, so 2 times 6 minus 5. 2 times the absolute value of 6 is 2 times 6 is 12. 12 minus 5 is 7. So when I plug in 3, I get 7. When I plug in 3, I get 7. So there's my V shape, like I knew would happen with all absolute values. And I'm only graphing those 5 dots. No, we don't connect them. We don't connect them because I only want these as my domain. I don't want the actual line. But that's it. That's how you do it. Graph f of x equals negative 3x minus 6. So this is a straight line that you probably remember from Algebra 1. So what we're going to do is we're going to locate this guy, which is the y-intercept, and we're going to put a dot right there at negative 6. That negative 3 is my slope, so I'm going to write it out as negative 3 over 1. Now that is a negative slope. that has me going down 3, right 1. Down 3, oh, I can't. So maybe instead of going down 3, right 1, I can go up 1, 2, 3, left 1, up 1, 2, 3, left 1, up 1, 2, 3, left 1, up 1, 2, 3, left 1. And once I have as many dots as I can, I'm going to do the best that I can to draw a nice straight line, which I'm really bad at, but it's turning out okay so far. So far, so good. Pretty decent straight line by me. Now I'm losing it. I'll give myself some credit. But that's how you graph a straight line. That is a function. Now, another way that you could do it, maybe the way we were supposed to do it, and we'll do it once, is that is supposed to be a straight line, is you take like all of these x values, like 0, and then you find out what f of x is. So f of x would be f of 0, so negative 3 times 0 minus 6 is going to be 0 minus 6, which is negative 6, and then you make your dots and then you draw your line that way. Either way is fine. Either way is correct, but I did it my way because it's faster.